This is TechSNAP, episode 419 for December 27th, 2019. Hello and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and I'm joined by Jim.
Hi, everybody.
This time around, I thought it'd be fun if we chatted about some tools that we've both been playing around with. Jim, let's start things off with Nebula. And this is an overlay network mesh VPN. You can call it by many names, but newly open sourced by Slack. We were lucky enough to be joined by Ryan Huber over on Linux Unplugged previously to talk a bit about it. And I saw you've been writing over at ours. You've clearly been doing some playing with Nebula yourself.
Absolutely. It's pretty cool.
Now, we've previously talked a lot about WireGuard on this program. Why do we need another VPN solution?
Well, Wes, we need another VPN solution because we need something that's not just a VPN. WireGuard, for as avant-garde as it is, and it's very avant-garde in a lot of ways, it's still a conventional VPN. It will tie 2 points together with a tunnel, but that's really all it actually does. You can route things across that tunnel, and you can have a lot of tunnels coming into one central server, but ultimately it's just point to point, and if it's not a simple star topology, it's going to be because of a lot of extra work you did on top of what amounts to a simple star topology. Nebula, on the other hand, it's a mesh. If you've got 20 nodes on a WireGuard VPN, then effectively all 19 of them are going to have to talk to the one in the center if they want to talk to any of the others. On the other hand, if you've got 20 nodes on a Nebula mesh VPN, when any one of them talks to another one, it does it directly. If it's just sitting in the same office, a couple of rooms away, and there's only a LAN in between machine A and machine B, they'll talk to each other without having to go through an intermediary. And if machine A wants to talk to machine C that's all the way across the internet, but maybe it's not in a convenient route to go through a central cloud server, that's fine. It doesn't have to go through the central cloud server. Again, it'll actually talk directly from A now to C without needing to go through that central, what Nebula calls a lighthouse.
And those lighthouses exist to sort of help that process along, right? You need some sort of publicly accessible node that can help set things up between various parties trying to talk to each other.
Yeah, but traffic never actually gets routed through the lighthouse unless you very specifically want to talk to the lighthouse, like use its Nebula IP address, because there's some service there that you want to access. If you're not trying to talk to the lighthouse itself, you're not going to be with your actual data. The purpose that the lighthouse really serves as a lighthouse is it's a way for two nodes to find out information about topology and how to reach one another. In particular, the lighthouse allows them to escape NAT, network address translation, even if neither one of them is actually port forwarded through their network.
Now, that's a fancy trick, and probably one you want if you're going to use this on maybe your mobile laptop. You're jumping all over networks. Possibly you're behind some sort of terrible system imposed on you by your ISP or carrier. How does Nebula actually go about making that work?
Well, before we talk about how Nebula makes it work, let's talk about how you were able to make it work already with a traditional VPN. Because, I've been escaping hostile networks for, quite some time with WireGuard and with OpenVPN before that. The key feature here is remembering that all tunnels, once established, are bidirectional. So rather than needing to port forward into a NAT-protected network, instead what you do is you set up a cloud server, and you have, each of your devices that are behind NAT obscured networks, they connect outbound to your central server. Then from there, you can tie those two tunnels together, and now machine A can talk to machine C through machine B, which both of them have punched outwards to in the cloud. You never have to set up any kind of port forwarding for that. That's a conventional VPN. What Nebula does differently is you've still got that machine that needs to be publicly addressable. Your best case scenario for that is going to be a cheap cloud VM. But instead of routing all your traffic through it, now what happens is machine A and machine C, they each know that they exist on the Nebula network, but they don't necessarily know anything about each other. Machine A says it wants to talk to C. Now it talks to the lighthouse and it says, hey, I want to get hold of C. How do I do that? Well, the lighthouse already knows that machine A reached it on UDP 4242 at the lighthouse, but the outbound NAT port from machine A's network was something dynamic. We'll say it was 51,000. Now, the lighthouse also knows that machine C reached it on 4242, and its dynamic outbound port was, let's say, 52,000. Now, the lighthouse itself can reply to either one of those machines by just sending UDP packets to that originating dynamic port. So if it talks to machine C using UDP port 51,000, that'll get forwarded through the firewall to that machine because that machine already punched that hole outwards.
Right. The firewall is expecting, or at least it might expect a packet back.
Exactly. Similarly, it can talk to machine A by hitting port 52,000 over there, and that will go into the originating machine, which punched that hole out. But the trick here is only the lighthouse is actually able to exploit that because it's not just about the port number. You can't just randomly crawl over the ports on the outside of a NAT network and, go through a pinhole like that. You need to have the same source IP address as what the machine that punched that hole outbound hit in the first place. But the trick here is UDP is a stateless protocol. It doesn't have a SYN and an ACK and, a well-defined session the way that TCP does.
Of course.
So to do a UDP conversation, you're basically just keeping that pinhole open for a relatively undetermined amount of time to see should we be expecting a reply back. So if you ask for a DNS request, you're going to send a packet out to target UDP 53 on a DNS server somewhere. And, within a few seconds, it will send some UDP packets back. And when it sends those packets back, it's going to send them to whatever that dynamic high outbound port was on your router. And because the IP address of the DNS server matches who you were talking to, and the port that it wants to talk to matches the outbound port, now NAT lets that through and forwards it back down to you. So what Nebula does here is it lies through its freaking teeth. The lighthouse has all of the necessary information, and what it does is it tells machine A, okay, what you want to do here, buddy, is you want to hit port 51,000 over there at this public IP address that machine C is hiding behind, and when you do that, don't tell it you're you, tell it that you're me. Use this IP address as your source instead of your own in your IPv4 packet headers.
That's sneaky.
So it does that, and these machines go through that claim they're from the lighthouse and target the correct port that machine C had talked to the lighthouse on, and the router over on the other end doesn't know the difference. So it forwards them directly through to machine C. And machine C already knows by way of the crypto, the keys that everything's encrypted with to begin with. It already knows which one's actually the lighthouse and which one's actually machine A, so it doesn't really have to worry about separating all that stuff out, even though it's all arriving on one port that in theory might look like one single stream. It knows by way of the crypto. So now machine C is able to receive these packets, whether they came from the lighthouse or from machine A, and everything just works. So in practice, when I set up a machine in my home office and a machine in my remote office across town on different ISPs and on a Nebula mesh network, and I ran an iPerf stream in between the two of them with no port forwarding, I got 20 megabits of throughput and absolutely nothing showing on IFTop on the lighthouse that they negotiated through.
That is so cool. You mentioned crypto there, and maybe we should touch on that next. I really like the way Nebula approaches this. It just felt simple, and it meant getting things started, adding new clients to the network. That was really easy.
Yeah, in a lot of ways, it's very reminiscent of WireGuard. Their crypto is based on the Noise platform, which is also underlies a lot of WireGuard's crypto. And I have to be honest here. There's a lot more to crypto than just saying, oh, we use Noise and that's it. And I'm sure there are a lot more lower level differences in the negotiations that I'm honestly just not that equipped to talk about. But I know basing it on Noise is certainly a good move. And also the actual generation is extremely simple. One way that it's a little bit more like OpenVPN than it is like WireGuard is you do need to set up a certificate authority, and then your CA is what you use to generate the rest of your certificates. However, with that said, it's so much easier than doing that under OpenVPN.
Right. You're probably imagining the hoops that you have to jump through if you've ever configured that, and it's painful. Nebula's not that way.
Exactly. With Nebula, there's literally one single command that you run to create your CA, and you have created it. And now you have your CA cert and your CA key. There's no wizard to walk through or a whole bunch of challenge questions or this or that or the other. You just tell it create CA, and it does. Once you've got your CA, now you just sign a bunch of keys for your nodes and your lighthouses, and they're signed with the CA's key. And then when you distribute the credentials to your lighthouse and to your nodes, you've got a copy of the CA cert and of that node's own key and certificate at each node. You don't need to pre-share keys or certificates for other nodes. All you need is CA cert, node cert, and node key, and that's it. Now, after that, they can all just trust each other, and they can dynamically exchange keys to establish everything because everything's signed with that CA certificate.
Right. Since all the clients are using the same certificate authority, they can trust that to tell them who can talk to them.
Exactly.
Well, you've already mentioned WireGuard and OpenVPN, and, well, the audience knows you, Jim. You'll love testing stuff, so I'm sure you've done some evaluating of the performance of Nebula. Is it good enough? Obviously, there's lots of neat features, but at the end of the day, you've got packets to move.
Yeah, Wes, I think it's safe to say the performance is good enough. It could certainly be better. WireGuard is roughly twice as fast, maybe a little bit faster, but the question is how many people are actually going to need that? In practice, the best way that I have to do a very high rate speed test on this kind of thing is just to set up a VM on my own Ryzen 7 3700X workstation and establish a tunnel between the VM and the host. Now, the downside to that is, you've actually got the same CPU hardware that's handling both sides of that setup, right?
Right.
But the good news is, it's I believe it's a 40 gigabit link. So, you can really test the top end on that. And on a slower system, I did that for WireGuard on my older workstation, which was a Xeon E3. And the E3 managed about 2.8 gigabits between VM and host over WireGuard. On the newer 3700X, I haven't done the same test on WireGuard, but I did that same test with Nebula, and I got 1.7 gigabits. Interestingly, that lines up with what Nebula developer Ryan Huber said he got on some large AWS instances. He said he got about 1.7 gigabits. So that seems like a pretty fair top end, for high-end systems. But the real answer here is that just about any two reasonable machines ought to be able to saturate anything up to a gigabit Ethernet link without a whole lot of trouble. The other worthwhile point of comparison is versus OpenVPN. And I think it's unquestionably faster than OpenVPN. I still don't really have an apples to apples because I haven't redone the OpenVPN test on the newer, faster system. But on the Xeon E3, OpenVPN topped out at about 400 megabits. So even if you tripled it on the Ryzen 7, which I don't think would be accurate, you would still end up considerably slower than Nebula was.
That's certainly good enough for my needs, and Slack's using Nebula in production themselves to transmit a whole lot of data, so clearly it's working for them too.
Yeah, Wes, my estimation is any relatively modern x86 machine, I think, ought to be able to saturate gigabit pretty well. I know my older Ryzen 7 2700 was able to saturate gigabit easily. And I would guess that you're probably going to have to get down to something like a Raspberry Pi before you have trouble hitting gigabit. But honestly, most of the time when you're down as low as a Pi, you're looking at 100 megabit links anyway. So I'm not sure how relevant that's going to be.
Yeah, that's for sure. It is neat when you've gone to this overlay network style because you can start to think about things a little bit differently, right? Suddenly you only have the overlay network to worry about. And as you move between different networks, maybe the network at your home, at your office, at the coffee shop, you don't have to care. Everything keeps its same address on the overlay network.
Yeah, that's not necessarily the use case that the Slack engineers designed it for, but that's the one that really has me kind of excited about it. I love the idea that I could, in theory, just set up all my PCs on my local area network, just leave them all DHCP. Absolutely not give a crap what their IP address is or how to port forward things or any of that. Just put them all on DHCP, put them on a Nebula network, and never use the unencrypted IP addresses for anything. They just know each other by their Nebula addresses. If I take a laptop out of the office, it automatically connects over the internet. I don't have to remember to use a different IP or remember to connect a VPN I don't normally have connected. I just use it like I always do. Bring it back in the office. I don't have to remember to disconnect that VPN or change anything back. Again, I just use the same host names, resolve into the same addresses that I always do, and it just gets there the most efficient way possible.
That's just so nice, right? Even when you're on the LAN, you don't have to worry about extra overhead, really. It figures it out.
Yeah, and I love the idea that everything all the time is like seriously encrypted, not just, ha lol, pretty much encrypted like your Wi-Fi network, but no, it's encrypted. I mean, imagine being able to say, well, I found out that somebody was war driving in my neighborhood and they camped out, a couple of houses down, and they spent, a day or so cracking my Wi-Fi password, but I don't give a crap. Good luck with that. It's all noise encrypted behind that with Nebula.
It's also pretty easy to get started. You mentioned the simple tooling. You'll just need 2 binaries, and since Nebula is made in Go, those are easy to get. You just go grab them from GitHub.
Yeah, there's not even an installer right now. You just grab a tarball for your particular distribution, whether it be Linux or Windows, ARM or AMD 64. There's one for Mac OS as well. Now, that's both the strength and the weakness. There's not a whole lot that you need to do on the command line. It is pretty easy to get it up and going. But for the moment, the problem is there's no built-in way to have it, automatically start when your system starts, or, start it and stop it like from a little applet or, system tray or something on the launcher. It's all literally command line. So every time you start it, you're literally changing into a directory and typing /nebula-config myconfig.yml. So it's not the hardest thing in the world, but it's not something that, I would want to have to tell a non-technical spouse or loved one how to use, much less, like a consulting client.
Yeah, it's definitely early days. I mean, Slack's been using it for a while now, but for the open source mode of Nebula, you'll find that the docs are definitely not complete. Could use a few bits, so you may be interested in contributing there. And there is some polish missing. As you mentioned, there's no Android client just yet. That's one I'm looking for.
Yeah, the lack of Android and iOS client, that's kind of a big deal right now. That's very limiting. And I will mention also the missing scaffolding. The scaffolding is pretty easy. I mean, it's the kind of thing that it's a pain in the butt to have to roll your own, but an awful lot of people, are probably listening to this and thinking, I mean, I can do that. I can write a systemd trigger to start that. That's not a big deal. And more importantly, that lack hasn't missed the folks at Slack. I spoke to Ryan Huber, one of the founding developers, on Twitter a little bit today, and he said that they actually do have an install wizard and wrappers for service configurations. They've got that in the works. They didn't want to just completely rush to that the day that they threw this code over the wall, because there's they kind of had some I think his phrase was pedantic discussions of when to stay in your own lane. They don't want to end up making things more difficult because they tried to jump too far to begin with,
Right. Keep it simple, and those that need to can build upon that, and over time we'll get more niceties.
Absolutely. Like I said, once that scaffolding is there, I can really foresee myself just taking the plunge and saying, you know what? All my stuff is all Nebula all the time, period.
I can see that too. We've already deployed it at the studio, and I'm using it instead of WireGuard, which it still works great, but Nebula's just a little bit more convenient. Despite all those warnings about, lack of docs and polish, it's also a lot of fun. If you're interested in networking, VPN, or just playing with cool new tech, I definitely recommend giving it a try.
Yeah, Wes, the one thing that I'm looking to get a little bit better is I did notice that the Windows port relies on OpenVPN's TapWin adapter, and I have found those things to be pretty unreliable. So I'm hoping that they'll find a cleaner way to implement that. Maybe they'll take a look at Jason Donenfeld's WinTon on that platform.
We can hope. I'm sure there's going to be bright things in Nebula's future. If you'd like to learn more, we'll have links to Jim's excellent write-ups, Slack's announcement, and, of course, the GitHub repo over at techsnap.system/419. We've talked a lot on this show about some of the concerns around artificial intelligence, and also just how widespread its use has become in the modern era. And while it's relatively simple to understand some of the higher-level concepts, there's a lot of moving pieces going on, different frameworks, approaches, methodologies. So I was really pleased to see your article, which not only provides a great overview of really what we're talking about when we talk about machine learning and artificial intelligence, but also has some really good tips on how people can actually start playing with it, even right in a browser.
Once you get that first entry, it's easy. But if you're not sure how to get started, you can easily spend hours just flailing around on Google, not really getting anywhere, because everything you find just assumes you're already a data scientist.
Right. Don't you read papers on this all the time?
Yeah, let me go ahead and link you to the matrix algebra necessary to describe the simplest possible perceptron that was designed in 1950. And no, that's not what I want to do. I want to classify some freaking images, okay? So, Wes, did you ever watch The Price is Right as a kid, the old game show?
Oh yeah, I might watch it today too.
Yeah, you remember Plinko when they would have the contestant pull a giant lever and it would throw a ball up to the top of a big series of pins and it would bounce around down the pins semi-randomly, and then which output chute it came out was what prize or how much money that contestant won?
Yeah.
So that is what pachinko is. It's this series of all these little pins, and it produces you with it's not really a formally defined outcome, but you can't call it random either. It's best described as probabilistic. So Price is Right, Plinko, or Pachinko, it's not usually going to give you the $50,000 grand prize, right? You're usually going to get the dishwasher or the microwave, but sometimes you might get the other one. And, the probabilities of that, it's dependent on where those pins are placed and how the ball is likely to bounce off of them.
Right, the internal structure of the board.
So this is basically the way that a simple neural network actually functions. When they say it's like a layer of weighted values, those weighted values are like the pins in a pachinko game. And it makes the data as it falls through the neural network, it makes it more likely to get funneled towards one of your possible outcomes, depending on the properties of the data itself. But it's all kind of probabilistic. Each one of the layers that it falls through nudges it in a different direction until you get to all the predefined outcomes that the neural network actually knows about. So you start out with a picture of a cat, and there's no formal logic that says, hey, you need to look for like furry pointy ears, or you want to look for slit pupils. You never define any of all that.
Right. Otherwise, we would have to describe how to identify a cat. That's one, not that easy to do, and B, doesn't really scale.
Yeah, it's incredibly difficult. Whereas on the other hand, you can take a neural network with basically randomized kind of mild, moderate values, and you can feed it a whole bunch of cat pictures and tell it you expect it to come up with cat. And, it's going to be very, very bad at that at first. And a lot of those images are not going to come out of the funnel, this is cat. They're going to come out the funnel that says no cat. But every time it gets the answer wrong, you're training it on data that you've already tagged. So it knows it got it wrong, and it nudges some of those values a little bit differently. And it back propagates that from the last from the last layer in the network on up. So each one of these changes makes it a little bit more likely to get the right result.
Right. And this is really where the learning is happening, right?
Exactly. So you never have to know to tell it what to look for. It figures it out as it discovers that the probabilities start to line up with those tags that you gave it. Now, once you've done that, the odds are very good. If you did a good job when you created your data set to begin with, odds are really good now when you feed it an arbitrary picture of a cat, because it's learned how to nudge that data down through there. It's going to end up in the right funnel to say cat or no cat.
And it turns out, well, we may not always care about cat pictures in particular, although if you ask the internet, I think they would say they do.
Bite your tongue.
It turns out that kind of classification is super useful in a huge number of problems.
Now, the other thing that we should talk about real quick in terms of terminology, because it comes up a lot when you start reading about neural networks, there's two different ways of using a neural network that are basically entirely separate from one another, but you need them both. One is training and the other is inference. So training seems pretty obvious, and it's exactly what it sounds like. That's that period of time when you're feeding the neural network that, doesn't really know what anything is. You just barrage it with cat pics until it learns. Inference, on the other hand, is when you use that now trained neural network to get the answer that you want out of the data that you feed it.
Well, that's all well and good at the high level. But to really get a better understanding, you're probably going to need to get some hands-on experience and actually start playing with some of this technology.
It's not even so much the tool, Wes, as where you find it. So one of the things that you'll encounter really quickly when you start searching for, how do I get started with machine learning or artificial intelligence, everybody's talking about Jupyter notebooks. Azure is like, come to machinelearning.azure.com and, get started right away with useful Jupyter netbooks. And, you'll see references to it on AWS and Google and everywhere else. And you're like, okay, but what the heck is a Jupyter notebook? Now, the answer to that is it's a fancy way of running Python code in your browser. It's pretty cool when you load up a Jupyter netbook. It's just a web page that has Python broken down into little individual blocks, steps, and you can wrap it up with markup language and images and whatever else you need.
Right, make it look pretty or explanatory or documented.
Exactly. But it's not just a how-to. You can click play next to each one of those little blocks of code, and it will actually execute it running on a VM in the background and show you the results right there in the browser. I played around with a lot of these things. I set up a Jupyter platform on my own hardware, and I tested it out at AWS and Azure and several other places. But by far, the winner for me was Google Colab.
What makes Colab a better experience?
Well, there's a lot of things that do. The first thing is, unlike most of its competitors, Colab is like not just free if you don't do the wrong thing. It's free. If there is a way that you can click something on Colab and manage to spend money, I haven't found it. They don't ask for a credit card, nothing. You can just get right there in the browser and, get it started and play. You can be doing machine learning stuff literally within seconds from landing on a Colab page.
That's really nice because, these cloud vendors, they make it very easy to accidentally pay for something.
Yeah, I'm not going to lie to you, Wes. I get the cold sweats every time I have to navigate something in Azure or AWS, either one, because I feel like, yeah, there's this free tier, but I'm not quite sure when I'm going to click the wrong thing. And the next thing you know, I've got $1,000 bill that month.
One thing that's nice about Jupyter Notebooks is that there's also a ton of them out there. So once you've got an easy place to run them, that means you have access to a lot of things that are already broken down and you can start playing with. So what did you choose to play with?
So I started out with image classification. That was in my head of like, that's the thing that I want to start with machine learning. I just want to be able to feed it a picture and say cat or no cat, or, hey, maybe tell me if there's a dog or a mountain bike or what have you. But that was my goal. That was my hello world for AI, was being able to just process photographs and get told what's in them. And I found an article on Medium that pointed me to a hosted notebook on Colab, and from there it was stupid simple. You click play on a bunch of code blocks that are annotated, telling you what they do, and one of those code blocks prompts you to feed it an image from your computer, and it loads that into the browser and processes it and gives you a little chart telling you the top 4 things the classifier thinks might be in that picture. That's all there is to it.
That sounds so easy.
It really, really was. And the cool thing is that's not the only thing that's easy, because all this stuff really is just Python code, that you're seeing in the web page and running in the back end. There's a download link to just literally download that Python and run it on your machine. There were a couple of little extra hoops. The notebooks, they frequently don't tell you every library that's pre-installed, universally across that platform. So you may have to figure out a couple of dependencies to, install on your local system. But it's like Pillow is a really common one, which it turns out is a Python library for manipulating images. But it's really not hard to figure that out and satisfy those dependencies. And now you can run that code on your own machine, and you can do things like I did, which was, dike out the code that prompts the user to upload an image in the browser and replace it with a simple loop to iterate over all the files in a given directory and classify each one of them, and then open up an output folder and write each one of them back out again with the classifier results tacked onto the bottom of the image. My journey from zero to holy crap, you guys, I'm classifying images was maybe 4 or 5 hours start to finish. And at the end of that, I had code on my machine that was allowing me to process hundreds or thousands of images at about 10 photos a second.
Right. We're at this kind of great point where a lot of the tooling has matured enough that unless you're doing something cutting edge, someone's already implemented at least half of it, and you can just tie things together to get started.
Wes, I need to go ahead and make one thing really clear. If I haven't already, Colab is awesome. The other really cool thing about Colab is it's not just free, it's incredibly powerful for a free service. The CPU instances they're not quite as fast as my own Ryzen 7 3700X, sitting in my office, but they're not that much slower either. And more impressively, you can even select GPU instances. Once I got done with my image classification, I started playing with Google Deep Dream, which basically shows you pictures of what the AI thinks it might be finding in your photos. And from there, an Rs reader in the comments said, hey, you guys should do something really useful with this. Have an actual product like, I don't know, colorized black and white pictures of the rainforest. So at this point, I have all of 2 AI projects under my belt, right? I've classified images and I've done Deep Dream to turn them into, Lovecraftian nightmares, right?
Absolutely.
I feel like the little girl in Jurassic Park. I'm like, this is Unix. I can do this. So I Google for something to colorize black and white photos. I immediately come up with something called Deoldify. There's a Colab notebook for it. I open it up. You select a GPU instance, and less than 5 minutes from when I first read this dude's snarky comment, you should colorize an image of the rainforest, I had colorized a random black and white photo of a freaking rainforest using a GPU-backed instance on Colab.
That is fantastic. You might also want a GPU instance if you're doing some training, right?
Typically, any really intense workload, you're going to want to run on a GPU instance, not a CPU instance. The GPU is able to process the types of calculations that machine learning needs orders of magnitude more faster than a general purpose CPU because they lend themselves really well to very, very wide parallelism.
Right. The architecture of these things meshes perfectly for the kinds of tasks and calculations that are used in machine learning algorithms.
Now, with that said, the kind of counterintuitive thing is that doesn't mean you want to do everything on a GPU, because the downside of running your workload on a GPU is that you have comparatively very little RAM to work with. And, you got to kind of move things back and forth. You got to get it across the system bus and out of the system RAM and into the GPU and then get it back out again. And the setup and teardown time for small tasks can make it where it's just not worth it. And that, order or 2 of magnitude faster processing you got out of your GPU, it's outweighed by the extra latency involved in having to set up and tear down the thing to begin with.
Well, you've definitely made the case for how easy this stuff is to try out. I'm curious if there's any more AI projects in your future over there?
Honestly, Wes, I think the answer is without a doubt. I don't know what they are yet, but I can't see how that's not in my future. It really is astonishingly simple once you get over that initial hurdle to figure out how to just go find a trained model and load it and, make it do your bidding, whether it's on your local machine with big batches on a ton of data that you have, or whether it's just, a thing here or there that you just do it right on the Colab page because you only had one to do, so it's easier just to do it there in a Jupyter notebook and be done.
And I don't think this tech is really going to go anywhere, so it's probably wise to get familiar with it.
I think you misspoke there, Wes. That tech is absolutely going places, and it's probably more accurate to say you're not going to be able to get away from it.
That'll do it for this episode of TechSNAP, but of course, you can find more over at techsnap.systems for our full back catalog, the show notes, which have links to everything we talk about in the episodes, and an easy way to get in touch. If you'd like more Jim, well, of course, he's writing over at Rs. And Jim, you're on Twitter at
JRSSNet.
I'm there too, at Wes Payne, and the whole network is at Jupyter Signal. Thank you so much for joining us.
See you in 2020, everybody.